Select the schedule that results from applying the critical path scheduling algorithm to the order requirement diagram shown for two processors. So first thing we need to do is do the critical path scheduling algorithm, and then we'll prioritize the tasks using that. Then we'll go ahead and make the schedule. Okay, so we need to identify the critical path first. So 13, 10, 8. Let's see, well, they all end at 8, so we really need to look at the first two numbers to find the greatest combination, and that's 13 to 10 is 23. So this is going to be the critical path, 13, 10, 8, or T1, T4, T7, because 13 plus 10 is 23, 11 plus 7 is 18, 11 plus 10 is 21, and 9 plus 10 is 19. So that really helps you get started in terms of the critical paths. Okay, so task 1 is going to be first, because that leads the critical path. Oh, and by the way, I didn't include this 8 because they all go to 8. So really that's not going to matter here. And then the next critical path is 11 to 10, which is 21. So I'm going to use T2 next. And then the next critical path is T3, T6 to T7. So I'm going to use the T3 next. So far these are all in numerical order. And then let's look at the critical paths that are left. Oh, and by the way, this 18 isn't used because it was already considered with this 21 from T2 to T6. So we're not going to use that 18 number. Let's look at what's left. We have a 10, a 7, and a 4. The 10s obviously are greater. And we're going to use the lowest number first. So the next task is going to be T4. Then we're going to be using T6 because that's the other 10. And that leaves T5 and then T7. This is going to be our new priority list based on the critical path scheduling. T1 through T4 and then T6, 5, 7. So really the 5 and the 6 are switched from what the numerical order would be. So now we need to figure out the schedule that will work with this. So when we look at these schedules, we're going to look for a couple different things. One thing is that the schedule follows the rules of the digraph over here. And the other thing is that it follows the rules of this priority list here. Tasks 1 and 2 start at the same time. That's fine because they're independent over here. And then 3 and 4 are next after task 1 and 2 are completed. And that's fine because task 4 follows task 1, and task 3 doesn't have anything that needs to finish before it, so that's fine. Task 5 and 6, those start after 3 and 4 are done, and task 6 needs to follow task 3, so that's good, and 4 only depends on 1, which was completed a long time ago, and 4 only depends on 1. And then task 5 is assigned, and then task 6, well, this follows a digraph, but it doesn't follow the priority list down here because task 6 should have started first, and then task 5. So this one does not follow the priority list. Let's look at this next one down here. We have task 1 and task 2 starting at the same time. Task 3 starts after task 2 finishes, that's fine. And it doesn't depend on task 1 either because it's first down here. It doesn't have to wait for anything else to finish. Task 4 starts after task 1, that's fine. And then task 6 starts after task 3, which is fine. And notice task 5 was starting after task 6, so task 6 was prioritized before 5, and then 7 starts after everything else is finished. This one does follow both the digraph rules and the priority list rules because task 6 was started before task 5. So this one actually works. Okay, let's look at this next one. Maybe there's another schedule that also works. So task 1, task 2 starting at the same time, and then task 3, that's all fine. Task 5 starts after task 1 and 2 are finished. That's okay because task 5 only depends on task 2. And then task 4 starting, and that's also okay because it only depends on task 1 finishing. Task 6, that one's starting after tasks 2 and 3. And that's fine. But once again, notice that task 5 was prioritized before task 6, so it didn't follow the priority list rules. This task 6 should have been started down here after task 5 This one doesn't follow the rule of the priority list because task 5 is started before task 6, so this one doesn't work. This one doesn't work because task 5 was prioritized before task 6, so it doesn't follow the priority list. And this one down here, see task 1 and task 3 starting, and then task 4 starting, but that's listed to start before even task 1 completes, and that doesn't follow the rules of the digraph, so this one doesn't work either. Okay, so this is the one schedule that follows both the rules of the order requirement digraph and the priority list based on the critical path scheduling.